In section 10.4, we're going to look at conic sections, which is a very vague, broad term. When we talk about conic sections, we are using this as a vague term to talk about a slice through basically a cone and the different shapes it makes. So we're going to be looking at cones, circles, ellipses, parabolas, and hyperbolas. How do we know the difference between all of these when we're looking at equations for graphs? Because they look very similar. Okay. Well, let's start with the first thing that you guys ever learned about, which was parabolas. If we start with parabolas, let's talk about that. Well, we know parabolas, when we look at their equations in standard form or general form, only have an x that's squared. That's how we know the difference between a parabola and basically anything else. They'll have only an x squared term. They'll have a y, but it won't be squared. It'll just be a regular y. Now, if you have just the x squared, it's a standard parabola that points either up or down depending on whether a is positive or a is negative. So that is when we're looking within x squared term. Now, if somehow you looked at a strange term where the y was squared instead of the x, is still technically a parabola, but if the y is squared, it's on its side, like in part B here. You'd have if the y is squared instead of the x, it's just a parabola on its side. So if you have only an x squared or only a y squared, it's a parabola of some kind. What we're used to is the x squared parabola, which either points up or down. If it's a y squared parabola, it's on its side, pointing right or pointing left. Again, the reason why we don't see this one a lot is because it's not a function. It doesn't pass the vertical line test. Now, if you have x's squared and y's squared, there's an issue. If you have x squared and y squared, it could be a circle, an ellipse, or a hyperbola. The question is, how do you know which one? Well, we already said that we know circles and hyperbolas both have a plus in between their x squareds and their y squared. So that helps out some, that circles and ellipses both have a plus. Also, we know that if the radius is the same for both the x's and the y's, then what? Then it's a circle, because then you're going to go left and right the same amount that you would up and down. So if they have the same radius for the x's and y's, you will have a circle. If you have different, so if you have same radiuses for x's and y's, you're talking about a circle. If you have different radiuses for the x's and y's and you still have a plus in between, then you're talking about ellipses. Be careful with ellipses because your c squared is actually a squared minus b squared. I know you have a plus in the equation, but when you actually look at the c squared equation, you're going to have the reverse. You're going to have a minus sign. And for hyperbolas, they're kind of their own little beast with, instead of a plus, you will have a minus between your x squared and your y squared. Be careful with the hyperbolas, though. It does matter which comes first before the minus sign. If x comes first, then what we'll have is we'll have a, so like on this first one, when the x comes first, we have a graph that opens left and right along the x-axis. But if your y comes first instead, then you'll have something where it opens up and down instead on your hyperbolas. So what do you do if you have these all jumbled up together like you do in 10.4? How do you know which one's which? Well, let's take a